Hello. In this section, we will discuss about the analogous system, force voltage analogy, force current analogy, and the mechanical equivalent network. Analogous means we draw the one system is equivalent to the other system. Now take a simple RLC circuit. Here we apply the KVL and write the equation 1 and 2. Now, in the second diagram, we take the parallel RLC circuit and apply the KCL and write the equation 3 and 4 by applying the Kirchhoff's current law. Now compare these equations with the standard equation of the mechanical system, which is represented by the 5, equation 5. Here, the force is analogous to the voltage E, mass is analogous to the inductance L, stiffness is reciprocal of the C, damping coefficient is the analogous to the resistance R, displacement is analogous to the charge Q. Now pause the video and write the force current analogy. This is the, I hope that you have already write the force current analogy. This is the table where the force is the analogous with the current I, mass is analogous of the capacitance C, damping coefficient is the analogous of the conductance G, velocity is the analogous of the voltage E. The torque T is analogous to voltage E, and this table is known as torque voltage analogy. This is the table for torque current analogy. Draw the analogous circuit for this mechanical system. On the right hand side you can see the analogous diagram of this mechanical system. What are the procedure? How we can draw the mechanical equivalent network? First we draw the reference line. Second step is to select the node according to the displacement. If there are the two displacement, then we select the two node. If there are three displacement, then we select the three nodes. Connect one end of the mass to the reference line. Similarly, we connect the other element and apply the nodal analysis for writing the equation. Take an example of this. Here, the mechanical system having the two masses M1 and M2. So first we connect the one end of the mass M1 and M2 to the reference line like this, and then connect the B1 and K2 between the mass M1 and M2. We have already selected the two nodes according to the displacement X1 and X2. Then one spring is connected between the mass M1 and the reference. Here we connect this spring between the X1 and reference line. B2 is the friction force which we connect one end and another end to the reference. Similarly, we connect here and we draw the force. This is the mechanical equivalent network. Thank you so much.